All right. We're here with the engineering design in Omniverse. I think Edmar got stuck in traffic on his
I'm here.
there he is.
Where's Jen, though?
I don't know.
I
Her
saw her a
camera's not
second ago.
working.
There she
Here we
is.
go. Hey. Jen's back from vacation. So last week I was here all alone, and I think
Now
I
it's a
was
party.
pretty boring. So I'm really happy. I'm glad Jen's back. I'm glad Edmar's here, and of course we have our special guest Gus.
Yeah, who is
And-
that guy?
Yeah.
Hi. Can you hear me okay?
Yeah.
Hey, Gus.
Hi. Is there a chat somewhere I can see? I don't see chat.
Yeah, there's some comments
By
on
the chat comment, I see. All right, cool. Just
Yeah.
making sure I can see everything. Hi.
And Gus is from the Isaac Sim team. Is that right? Is that the right way to say it?
Yeah, I'm one of their science minions. I do a lot of prototyping and talk to customers and answer questions and squash bugs. My background's in physics, so I'm not formally trained in like engineering, so I don't have the kind of software development chops to make consistent contributions to the team. So mostly I focus on my research and my time.
Well, you could have fooled me. You make a lot of contributions, man.
No. I'm like a fumbling toddler compared to the other people on the Isaacson team when it comes to like developing code. Like I have seen things. They're very good.
You're a great help to the community, so it's really cool that you're here today. I want to say really quick, I think your microphone might be, your laptop microphone might be what's activated in StreamYard and not your headset. We can hear you, but you sound a little muted.
Let's change that.
Check settings in the bottom.
Yes.
How about now? Does this sound any better?
Yeah, oh my gosh.
Yeah.
Yeah, you're like a new person.
There we go. And no echo. That's way better. Much better. Thanks.
I'm sorry about that, guys.
No, you're
No,
good.
good. Believe me, I've done much worse before. Jen, you're back and you're incredibly quiet, which is very is that par for the course? Because you just pop in there with this amazing insight at random times.
Yeah.
This is not everyone probably thinks it's Jen's first day back, but she's been back a few days, so she maybe we need to get you some more coffee.
Well, mostly I have sinus infection stuff going on.
Oh, shoot.
I'm sorry.
Yeah, it's all good. It's what I get for being on a plane, and then especially 14 hours, 9 hours.
I can hear it now in your voice.
Yeah, so that's why I try. I've been a little bit quieter. Some people are like, "Are you talking?" And I'm like, "No, I'm not." So
no, I'm not talking. Yeah.
Well, glad to have you back. Missed you.
But did you though?
I did. I absolutely. I think everybody did. I think the community missed you. Speaking of the community, you want to go over GTC really quick, because I got to tell you, I am super excited about GTC. Every day we get closer is just more excitement, because it's the first time we're going to be able to meet a lot of people in the community who are coming in real person. This is the first GTC, and I believe it's 5 years. Let me take off the brand thing there for a second so that Eric is not. Where is it?
Yeah, I'm not as important.
There you go.
There we go. Oh, there we go.
So this is coming up really quick, literally like 2 months away, March 18th to 21st. Now, we know that it's hard for everyone to get there, obviously, because it's in California. But for those who can make it, please check out the GTC website. Check out all the sessions that have recently been posted. We now have pages broken down by topics, so you can see all the sessions related to your favorite topic. And perhaps most importantly, let us know, one of us here, if you're going, because we would love to meet with you. And if we can help set up meetings with other people from the NVIDIA team, whether it's the Inception team, if you're involved with a startup, if you want to talk to Miles Macklin because you got some burning work questions, I know he'll be there. Audio to Face team will be there in full force. RTX team will be there, of course. So if you have interest in setting up meetings, or you want to meet with one of our partners, someone NVIDIA works with closely, is another great reason to get in touch with us, because we can help facilitate that. Easiest way is you can shoot me an email, edmar@nvidia.com. You can go to Discord. We have a GTC channel. You can ping me there. and we'd love to help set that up. I think the keynote has also been posted, the day and time and everything, so you can add that to your calendar now. And for folks who can't make it, like it says at the top, there's going to be lots of virtual stuff. Won't be the full deal, but we're going to try to get as much as we can jam-packed, including we're going to try to do some live streams, daily live streams, I think at least on a few of the days. We're going to do like day recaps. So we'll see how everything works right now, but we're working hard to get that going. There's going to be an OpenUSD day on Tuesday that week. So a full day revolving on OpenUSD sessions. Aaron Luck will be there, so if you can watch his awesome USD series playlist, you can talk to the developer himself there. And then to cap it off, perhaps most exciting, we have an OpenUSD happy hours, which I'm another reason I'm looking forward to seeing Jen there. We're gonna have lots of people from the community and the dev team hanging out, and we're gonna have drinks, hors d'oeuvres. It's gonna be a lot of fun. So anyway, GTC 2 months away. Go ahead and register now. We'll pop in a code in the chat. It gives you a 25% discount. And there are also group rates there. There's a student day if you're a student. So lots of cool things. Yes, we're looking forward. Eric, you're going, right? And Jen, you're going, definitely.
Yeah, well, and so is Gus. We've got a hands-on lab. So if anyone wants to come, and we're gonna this thing we've been working on in this car, we've got a lab about it.
That's awesome.
So you can come and play with it hands-on, and yeah, it's gonna be
fantastic. Cool. The other thing, I'm going to post this link in the chat, but this just I guess two things. One, we had a fantastic live stream, a couple live streams this week. One, Ashley, who is on our team, she had a great live stream with Michael Wagner. So if anyone out there has worked with MetaQuest 3, she showed live how to get it working based on Michael Wagner's great article recently he posted on Medium and LinkedIn. That was really fun, really cool, just because they were collaborating on each different workstations and they were able to see each other live in the scene. Pretty wild. We leveraged Yumi Studio for that, so big thanks to Yumi for that. And then yesterday we had the RTX Remix team on. For everyone who's interested in modding, RTX Remix is now in open beta starting on Monday, this past Monday, so it's open right now. We had the RTX Remix team on there. We'll post a link to all of our live streams so you can check one of those out after this amazing live stream about to right now. And the final thing I want to say is the documentation team has just released a really critical survey that we could really use your help on. They put together a really short list of questions, which will really help the team nail down how to improve the documentation, what needs to be added, what videos are needed, what more tutorials are needed. But we only know what to do based on what the users need. So please take a few minutes to fill out that survey. I'll go ahead and pop the link in the chat now. And then without further ado, I think it's time to get the autonomous robot talk going.
Yeah. And first, I just want to show you where we're at. Let me share my screen here. And if you take a look, I've got a USD pipeline going so that we can, so I've made some updates to the CAD model. I've added, changed the upper arms. I've added rear uprights that are halfway decent. I've added some structure to the chassis that actually links up with the suspension. So it looks a little more realistic versus you can see in the front, everything's still floating in space. And we've got a USD pipeline so that you can just re-import that CAD, kind of copy it to a folder and relink a few files, and it'll just all rig for you using the USD sublayers. Because remember, those USD sublayers, they work like macros. So if you set them up right, you can kind of develop a pipeline where you just bring in new geometry and everything kind of rigs up. And then you see these cones we've got. That's what we're going to be talking about here in just a minute. But first, let me show you with a chase camera. I've got the car hooked up to a gamepad, and I'm just driving it right now with a gamepad. I'm not a great driver, but
turn the lights on, man.
Oh, usually it blows up if I hit a cone. That's lucky.
The lights are off because there's not a whole lot to see in the track.
Yeah, it's just kind of a basic.
Oh, this is a track you made, Gus.
Yes, and I made this manually. So I want to make procedural tracks so that we can create domain randomizable environments for training on different racetracks, right? We want to be able to, we'd like to be able, the goal, the dream is to create a demonstration pipeline to go from full synthetic data in the sim to a deployable zero-shot learning agent for racing, like cone-based simple tracks like this. Like we'd like to be able to load the agent on the car, put the agent on the track, and then have it start driving slowly at first, and then faster and faster and faster as it loads the track. I think demonstrating that pipeline is like a pipe dream of mine. It's a long-term goal, and this is part of that process. Yeah.
And do you mind if I explain a little bit of what you were just talking about there, Gus?
Sure. Yeah.
For those
please.
who are less familiar with artificial intelligence, who are watching.
Well, what do you think? I can elaborate more if you want me to.
Well, just talk about domain randomization. What's domain randomization?
Sure. So if you have, actually, if I had known I was going to get questions, like I have presentations on this subject that I could show you. So the domain of the agent is the space of possible inputs that it could receive during its activation. When you're talking about a
track, right? That's the domain.
Well, in this case, yeah, it's a track. So, but specifically, it's the images generated by the camera and the IMU sensor. Like those specific values are the domain, and the agent that you're learning, that's learning in reinforcement learning or through some unsupervised method. What they're learning to do is to perform some kind of mapping between that domain and your desired output. And it's a very specific, narrow channel that it learns. It learns specifically only the domain represented by the data that you feed it during training, right? So domain randomization is the process of parameterizing your environment in such a way so that you can create many, many, many random sensory inputs for the agent to be exposed to. And then the goal is that if the domain of the synthetic agent is broad enough, then reality should be contained within that subdomain. And if it works everywhere, it'll work in this specific part of the domain.
And what's zero shot?
So zero shot. So when we talk about transferability, right, we're talking about an agent that can perform new tasks, it can do things that it's never been exposed to before. And a lot of times they talk about how much additional data is needed to train the agent on that specific task in order for it to perform that task. So very, very early meta learning type experiments like MAML involved training the agent to get to some kind of stable position in its parameter space that was close to many, many, many other parameter sets that would be useful in doing many different tasks. And then you would train with a few examples to make the parameters more specific to the task. That was few shot. Zero shot is the idea of learning as you go. So you've never seen anything before. I'm giving you single observations, one at a time. And over time, you learn what you're supposed to do. You learn without any additional data. You have so that's the idea of zero shot learning. You have no additional training required.
And so in the case of this car, basically the idea is you create just a plethora of randomized tracks that you train it on, and then the model is smart enough that you can put it on a new track it's never seen before, and it can still drive around the track. Is that right?
That is the goal. And I have a couple ways that I think we can go about doing this. And I want to explore the lowest hanging fruit example of this with the community, which would be just straight reinforcement learning on a parameterized racetrack.
Right.
My research involves another way I think that we can go about this transferability, but I don't know what is and isn't okay to talk about.
Sure.
So,
well, let's keep it simple. I think if we just with the community, we work on just straightforward reinforcement learning pipeline. I think that's a great approach. Let's work on that. And Gus, we haven't talked about this yet, but Gus has offered to do a weekly live stream where we just work on some reinforcement learning together.
Yeah, we need to have regardless of how we want to demonstrate transferability and what we want to do with this like pie in the sky pipeline dream, regardless, I want a simple example for reinforcement learning using an imported robot and a loaded scene. We have some simple examples for like cart pull, that show off reinforcement learning, but I want, like for a JetBot, a very simple drive to this target to start with, and then eventually from there building up to racing on tracks. And
Sure.
this
But I think we're gonna
whole
say,
year
like,
we're
gonna have a
focusing on.
cone. We're just gonna have a single cone, and we're gonna say drive and hit the cone. Is that right?
Yeah, that's goal the first. That's like the zero with like we're gonna stand on this floor and not fall over.
And one
You
thing
know?
that Gus mentioned before is this idea of vectorizing. And what that means is you need to have macros and scripts set up so that we don't just have a single simulation of the car running at a time, but it will vectorize and make N, some number N of simulations that are all running at once. And that will let us train our models, well, N times faster, right?
So the I don't know, I won't say if it's N times faster or not, but the idea here is that if you're doing naive reinforcement learning and you're just like applying PPO with stable baselines 3 or something, your goal is to generate like as many rollouts as you need to do that proximal policy update step, right? The more parallel environments you have generating possible rollouts for training, the faster that process becomes and the faster training becomes as a result. So the vectorization process is about multiplying how much data you can generate per unit time, so you can train as quickly as possible.
Absolutely. Now, of course, the first step before you vectorize something, you have to build it once. And before you, and as you know, at NVIDIA, we have this philosophy of crawl, walk, run, where we don't worry about just absolutely doing the fanciest, best version of something in our first shot. And so what we're doing first is we've got manual tracks. I've manually built this asset. It's not vectorizable yet. And we're going to train it to drive around this one track, or we might even simplify the track before we train it so that it can only see kind of one row of cones at once. Because right now I see a field of cones, and that seems like it could be confusing for an AI. I mean, it's confusing for me, right? So I think we're simplifying, we're paring down, and just developing this stuff one step at a time. So right now we've got a manually created track, we've got a manually created asset, and we're going to manually train it using supervised learning with this trainer I've been working on. And I think depending on how much time we have, I might be able to show you where we're at with that trainer. But first, show us how you made this track, Gus.
It's really straightforward. Like, you're really talking me up here, and it's very, very big. Like, I want to show you how I did this. You're gonna be like, oh, we asked this guy to come on to show.
Well, but here's the thing though, right? Here's the thing is sometimes these simplest methods are the best, really. And because I think most people, when they've been doing track generators and that sort of thing, they would say, well, I'm going to draw a curve, and then I'm going to come up with a macro that draws cones or objects along that curve, right? And I think that this is almost more like a classic 2D video game approach. If you look at the classic 2D video games for their terrains, they would come up with tiles for their terrains. Yeah. And the tiles all link up together. So no matter how you place the tiles, the rocks at the edges line up. And this is kind of what Gus has done. And anyway, I'm going to let Gus show you. Let me put his screen up, and let's see how you did this, Gus.
So the original thinking I had was to use something. I think it's called wave function collapse. It's a method of generating procedural tile-like environments. And so to make the track, I was going to make individual tiles for like go straight, or here's an intersection, or turning left or right, or so many angles, and then define rules for how those tiles connect together to do some kind of like procedural generation. But to just start, I had to make like a proof of concept, which is what I'm going to talk about here. So when you open up a fresh stage, this is what you get in IsaacSim. It's empty. And we want to fix that. So the first thing we have to do is we want to create a ground plane. So we're going to create, and then we're going to go to physics, followed by ground plane. Bam. Awesome. And now to make our racetrack, we're going to make our racetrack out of cones. So in IsaacSim, we have a beta extension called our it's like an asset browser. So you can type in cone and hit enter, and it'll browse through all of the available assets from IsaacSim and then search for specific things that have cones in them. And here we have one labeled traffic cone. So I can just click and drag this into the scene, and it will load this this traffic cone as a new prim within the stage.
That first time.
Always takes a little bit, yeah.
Yeah.
So now we're gonna put it at the origin by just setting all the values to the default, and I'm going to lift it up just a little bit, because if we hit play, we see that nothing happens to the cone. It just floats in space, and we want the cones to be physical objects that the car is going to be able to collide with. So the very first thing we're going to do is we're going to give this cone a default collider and rigid body preset. So to do this, you can either go through add and then to go down to physics and then rigid body with colliders preset, or alternatively, you can select the prim and then go down to the add button here and go to physics, rigid body with colliders preset. And now you'll see that if I hit play, it falls to the ground, right? So now we want to make our track. So to start with, we're going to make a straightaway. Each square here should be approximately 1 meter on a side based on the default units in IsaacSim. So we're going to hit Control D to duplicate our cone, and then we're going to move one cone along. See this green line? We're going to change this to -1, and we're going to, or -1, and we're going to change this one to +1 to get our first set of cones. And then the rest of the track, all I do is I take these and then I duplicate them and then I move them to some distance. So here I'm going to put them at 2, and there's still, you see how this is mixed? It's because one is at +1, one is at -1. And this might be a little narrow, right? So we can select these 2 cones like so, and move these to 2. Let's do that here as well. So move these to -2, and then we'll duplicate the set again. We want to put that at, actually, I don't want to do that. I want to duplicate just 2. There we go. Because now we could do this. Yeah. Okay, so this might be a straightaway track, like a single tile, straight portion of the track. So now I'm going to create a prim, just an empty transform prim. I'm going to call it straight. Let's see, rename. And I'm going to put all these in here, and then I'm going to duplicate this. I'm going to hide that one so we can't see it, and then I'm going to change this one to turn, right? And now I'm going to add cones to turn this into a right turn. And the way that I did this is really straightforward. I just created a simple cylinder, and I set its radius to 2. Right?
Okay.
And now I can place cones around the exterior of the cylinder to make the turn that I want. So I'm gonna move that guy down to here, and I just manually, like, it's really not anything super like high tech or complicated that I did. I literally just duplicated and moved things around, and perhaps the most useful thing might be the organization of how I set this up, right? So we can hide this measuring cylinder now if we want to, and we have a right turn.
Well, you know what, Gus? The simple solutions are always the best solution.
Yeah, I mean, and it works. It works well. But you have to be careful about how you're setting that. See, I already messed this up because I didn't do the turn correctly. This is 4 wide and this is only 3. So this guy should actually be.
That's what I was saying before. Jen just pops in with these revelations. Quiet down, and all of a sudden, boom.
Well, she's right.
Insight.
It's true. It's the right. You got to start somewhere, and it's a good first step. So this might be like an example right turn. So we can call that turn, and now straight and turn are both in the same location. So I'm just going to move one of them over here, and then I can make another transform, and we'll call it palette. Create xform. We'll rename this. Oh, and now you get to see how bad my spelling is too. All right. And then we can, from here, because the palette's hidden, we can just copy like however many we want. So I want more turns. I'm going to bring that into world so it can be seen now. I'm just going to, and this is literally all I did is I just manually lined things up. And that's it, right? That's all I did for the entire track. It took maybe like 45 minutes. But now the goal is to, if we wanted to use like that wave function collapse method, we would export each of these components on the palette as individual prims. And then we'd have to edit a bunch of metadata that defines how they connect together. And then there's a specific tool that we have that we use for generating random warehouses that I was going to try and use to generate tracks. But yeah, that's all I did. Nothing crazy.
It's great though. It's such an effective way to make a track. And I would be curious, with this methodology, what tracks you all could come up with. So I would be really curious to see. It doesn't even have to be with cones. It could be with K-rail, or I was even thinking the F1/10 races are done in tracks made out of like corrugated. It's like flex duct that's been painted a matte black. And I wonder if someone could come up with some tiles like this out of that kind of a corrugated duct asset, and so we could make like actual F1/10 tracks to train.
One other thing I wanted to figure out is that there's another method that we might be able to use where we could create
create a curve.
Exactly. So you can just
Can you close the curve? Is it an option?
It is if you know what you're doing. If you don't deselect things on accident. All right. But so then what you could do is if you could find a way to make the mesh that you assign to the curve instead of this tube, some flat ribbon, and then that could be tape on the ground that is the edges of the tracks, right? So it'd be easy to set up some tracks with like racing tape on the ground or something like that.
Yeah.
So
absolutely.
That was something else I was considering. And there's someone on the Omniverse Discord has a script node that generates clones of a prim along a curve, and they gave me a copy of that, and I want to take a look at that and see if I can't use that maybe to put cones along. So use a curve to generate the edges and then drop cones along the curve kind of thing,
Yeah, that's cool. Yeah, I thought that could be great.
Yeah, you guys are giving me some bad ideas for extension developing at midnight. when I should be sleeping.
I'll
But
take
it's
them.
like-
If you're going to be up anyway developing extensions, I'll take them.
Just give me a list of all your needs, and
Right.
maybe it'll magically appear in your hands the next day.
God.
You know, so on this RTX Remix release we had yesterday, one of the features of Remix is that you could basically take a picture of a level of a game, and Remix will create a USD scene.
Really?
Based on. So I'm wondering, and I saw one of the games listed with RTX support on the ModDB website, which we're partnering with on this. I saw Trackmania. So I'm wondering if it's possible to grab a Trackmania map.
What about like
into
Forza or
Well, you know what? I think if I remember correctly, there is what was it? Is it Formula One? They have like a whole digital track of the Las Vegas
really?
one. I wonder if we could get our hands on that. That'd be pretty cool.
It'd be kind of fun to take those and make them 1/10 scale.
Yes.
It'd be awesome.
That's cool.
Bunch of ideas popping up in the chat. I see Ashley. Hey, Ashley. We were just talking about your stream earlier.
I had a good question from Zia. Asked if the floor has a given static friction. You can set the static friction of any of the objects, and with the physics system, you can say as a setting, because friction is between two objects, you can designate whether it will use the average friction, which is the default, or the max or the min friction between the two objects.
It's here. I think it's set in this
If you create a
physics material. Yeah,
I've got one here I can show on my screen. Let me do that. So right here under I've got asphalt _ rubber. That's because that's my friction coefficients between asphalt and rubber. And in this case, I've applied it to the asphalt and to the rubber, so the average to be the correct friction. But one idea I had is you could set the friction of the tires to be 0, and then for every material they might contact, set the friction you want between rubber and that material on that item. So on the ground, or if you have a gravel patch, that sort of thing. And then what you could do is you could set the physics settings to do the max friction, and then you'll have different friction coefficients between the tires and the various surfaces, which could be kind of cool. But anyway, yeah, you can set the friction, and it's not just static. You can set the static, the dynamic friction, and the coefficient of restitution, which is how bouncy it is. And here you go. Friction combined mode is right here. You can do average, min, multiplier, max. And same thing with restitution. Great question. Let's just see. I got to dig into that art. If we can get lots of tracks and stuff from RTX Remix, that's pretty valuable, I'd say.
That would be very cool. Yeah.
Yeah. All right. Well, thanks, Gus. And does anyone have questions for Gus? He's going to be here, and I was going to go ahead and start to show off where we're at with this trainer that is currently not launching for us. It's got errors.
Trainer.
So, yeah, I'm working on the Jet Racer trainer extension.
This is Chitoku.
Or not it's Chitoku's method rewritten as an extension.
Perfect. Yeah. Oh my God, that's awesome. That's such a cool way to do it. I like it.
And okay, I know exactly what's going on here. I just have to find out the path I'm trying to save images to. And there's a problem there. So let me just let's see.
Classic index out of range.
Self.save directory. Here we go. So let's resave this so it hot reloads. And I'm not debugging yet. Hello. Start the debug session. Now save it so it hot reloads. There we go. And the directory is, let's see if I can copy that. Just taking out the extra slashes. and then hiding all my top secret stuff. It didn't work. Just a second. It was app data local temp. Okay, this is where I save all my images. And one of these is going to be a GUID only. And if you see, basically, well, we'll get there. We'll get there. Let me get it launched first. Here we go. Here's the trainer. And basically, I hit this capture button, and it's not working right now, but it pops up the frame from the screen here, right here. And then you can click on it. So you click where that car should be steering to. And what it does is you can see on this screen, when I hit capture, it did successfully save it here. And then when I click on it, it will rename it and add the XY coordinates that I clicked on. To it'll prepend those to the name of the image. And then the system will kind of adds those to my data set. And then right here, you can click on train, and here you set how many epochs you want to train for, and it'll train for that. And then I'll have a second image here, so you can hit capture and then evaluate, and I'll run that through the model, and the model will put a dot where it thinks you should click. And so we're basically training the AI, given an image, where should that click point be on the image? And we'll use that, if the point's over here to the side, then we'll say, okay, we should steer off to the left a little bit, right?
So this is human annotation.
Human annotate, we're just annotating images by hand, just in a relatively streamlined way. And that's where we're at. And the problem I am running into, and this is why I'm so glad Jen is here, because Jen is much better with Python than I am, is basically whenever you click on that button, whenever you click on that capture button, it needs to redraw the image. And then whenever you click on a location, it's got to redraw. I've just put like a red circle, and it should change the position of that circle. And right now, so this is my UI definition. Let's see here. I've got this function that will run whenever you click or whenever you make a change. This is like the refresh the images function. And here on mouse release, this function runs when you click and release the mouse on the image. That actually grabs the point you clicked, and it should move the dot to that point. But here's the original definition of the images. So I've got an image. This image stack is a horizontal stack because I wanted to have two images next to each other. And then the first item is a clickable canvas, and that's a canvas frame. A canvas frame is a UI element in Omniverse that can receive clicks. And just saw an interesting question roll in. Can this be automated using a curve along the track with set points against the position of the car using a 0.5 of center? Oops. I think you could absolutely automate this process. I'm not quite sure how to do that, because you have to find, I'm not quite sure how to do that.
If you were thinking about automating the process, because that might also sound a little bit similar to just having like an on rails type of situation.
Yeah.
So if you wanted to actually automate it, something you could potentially do, and this is just an option, there's probably more out there, is based off of the image that you have taken or you captured. You find some middle distance between some left cone and some right cone. And then you would place that dot there. So you could potentially just have it going So that's one way that you could do that.
Well, along the same token, what you could potentially do is just drive the car and capture every frame along with the steering angles and use that as automatic training data. The reason we're not doing those is because I don't have them working yet. And this method that Chutoku has written, I know it works. I know he's done it. I know he can get cars driving with it. And so I'm going for this, like the minimum viable product. What is the absolute simplest way I can get this thing working right now? So, but remember, this is just the first way. So it'll definitely improve over time. Okay, so we've got the clickable canvas. So we can receive mouse clicks on that first one. So you can click on your location and receive that input. And then there's a Z stack, which lets us stack things on top of each other and choose the order. And this lets us have an image with a dot on top of it. Otherwise, when you draw the dot, it actually blanks out the image, the image doesn't show up. It's one or the other. So the Z stack lets us show both. You can see here we've got the image. And then we've got a vertical stack. And then what I've done here is to place that dot where I want. I've got a vertical stack with a spacer and then a horizontal stack with a spacer. And I can set the size of those spacers to move the dot where I want it to go on top of the image. And then here's the dot. And yeah. And alignment is left top. Well, it might be a little off. We can tweak that. So the problem is, so here I've initially defined this UI, these UI elements. And what I want to do is whenever this replace image function runs, I want to replace those with the new image and the new dot location. And I've tried a number of things. Probably the most successful thing I've tried is I just define this clickable canvas. Let's see if this works. And then in this replace image function, I just draw it for the first time, kind of. See if that works. Let's see how this works. Oh, I've got one of these GUID only images. That's just a bug I haven't gotten around to fixing. All right, cool. Yeah, it's not working right now. Well, shoot. So I'm curious what approach you might take. I've tried. I'm running clear here. Probably don't need to do those anymore. Let's see if that's the problem. I had it drawing like this. The problem was that every time you clicked, it added another image to the stack instead of replacing the second image. It was kind of weird.
I'm so bad with this kind of stuff, like UI programming, UI design, getting image. It's like my brain turns blank.
Well, this is the stuff where you get caught sometimes. It's like
it is. No, it really is. That's where all there's a lot of really important effort that gets done there, and I really value the people who are capable and willing to do that.
Okay, I can kind of show you how it works now. So look, so you hit capture, it does a new image, and I can click on the image.
So then you drive in between, right?
Yeah, and so now let's hit this run here, and now I drive a little bit and stop.
And you drive capture, to your target.
Click.
You drive towards your target that you're trying to get to, right?
Yeah.
Capture, click. Capture, click. So it's not too bad, really. Capture, click. I mean, if I were a better driver, it would probably be even better.
Or if you had someone driving while you were capturing.
Totally. Capture, click. capture, click. Oh, shoot.
Oh, no.
I'm distracted driving here.
So Chitoku's method is recording where you clicked, it's recording the image, and it's recording the commands that you gave to the car?
No, it's so far, all it does, I can show you here, is it's got the image, and pre-pended are the X and Y coordinates that I clicked on.
Sure. But Chitoku's method, like, how does it map from the clicked image to the action that the car is going to take? How does it learn that?
I haven't gotten that far yet.
Okay, no problem.
But,
That's fine.
but my guess is that it just calculates a trajectory. You know, like you can calculate the angle from the bottom.
Okay. So it probably gets like the velocity of the estimated velocity of the car and how much time there's been between images, and the camera properties and where you click to figure out like all the vector positions for where you went, and then it just fits a curve or something.
Not nearly as fancy. No, I think it just does based on the image. So for this image, which direction should I be steering? Then it has maybe a fixed throttle. There's no annotation of the throttle or your speed.
Interesting.
So I think it's really just basic.
I wonder if you could make like just a whole library of images and then have the policy just some transformer over the library if you take them in order, right?
Yeah.
Then the output of the transformer would be the next.
It could be, but I don't think that's what's going on here. I think it's just doing trajectories. But like I said, I haven't gotten that far yet. Right now, I'm just really excited to show that I'm getting this data, right? And the part that's missing, though, is there should be a second image popping up right here so that I can click on evaluate and run that image through my current model. Because what I can do, I can hit train, and it's training right now off of that data. That's already wired up.
Training what? I don't understand. I guess I'm still missing.
Well, the model is based on each image. If you give it an image, it will give you an X and a Y for where it thinks I would click on the image.
Oh, okay.
So you give it an image,
okay.
an X and a Y coordinate.
Sure. Oh, and then it just extracts the turning commands from the X and Y coordinate that it predicts. Yes. That's super. All right.
Super elegant, right? Isn't that just elegantly simple?
I don't know. I'm curious about. I mean, it works in reality. That's how we do the jet racer stuff, right? So
it works.
I'm really curious to see this in action. That's really interesting.
Well, I think as long as we have a little bit slower throttle, like we're not going to go max throttle, like Stephen Gong does really high throttle, right? He's going for high speeds. We'll just have a moderate, kind of a low speed, a slow, kind of constant speed, and just let her rip, let her go.
Sure.
Yeah. And let's see here. And from my understanding, it takes maybe like 200 images to train his model, which is, how many are we at? I can tell you, we have 16 images so far. So it'll take a minute to generate all the images, but it's really not too bad. And yeah. The great thing is at the lab, there'll be two partners. And so we could absolutely have one person driving with the keyboard with another person just annotating as fast as they can. And so the reality check, that's what I'm trying to get working, is I want an image to show up right here. If you click evaluate, I want it to run that through the model and draw a dot where that AI model thinks that it should have pointed. And what you can do then is you can drive around the track and click evaluate and see how good your model's doing and see if you need more data.
You could probably reduce. What if you just drew the evaluation dot on the same image as the red dot? So you could see how close they are right on the same.
Do like a green dot or a blue dot instead?
Yeah. That would save you horizontal space on the UI too.
I love it. Another idea would be to draw it on the viewport with each viewport.
That would be cool. That would be.
So you can as you're driving around, you can just see, be like, oh shoot, that's a bad spot. So there's a lot of cool ways we could do this.
Yeah.
I like for now though. I like your idea of just drawing the dot on the same image.
Yeah.
Let's see if we can get that to work real quick.
Just different color.
So we'll just let's see. to style 1.
Next step is to launch an augmented reality using eye tracking to locate the dot and blink to click. Man, if only.
You probably can. There is the.
I mean, we have XR, right?
Yeah.
And there are VR headsets that have eye tracking.
You don't even include that. Just use Toby's eye tracker.
Oh, okay. So like some camera image of the person.
Yeah. So basically, it's like a webcam that basically
Yeah.
tracks where your eyes are, and then it'll put it on the screen too, so you can actually like see where it
Oh
goes.
my God, that'd be cool.
Those are wild, actually. They do
Turn
work
around.
really well.
Next to each other. Maybe because I have them both in H stack.
Jen,
So
do you
what
use that for gaming, Jen?
What, the eye tracking?
Yeah.
No, we were experimenting it at some of my last couple of jobs on like, what, like how it works and is it viable for certain stuff, but not too much.
Got you.
Yeah, I'm just going to give these. Oh, it's going to put them all together. Equals 30. Give these static values for now, just for testing it, right?
Yeah.
Might fail. Nope.
We got 3 dots.
That was. Why do I have 2 red dots? Oh, because I didn't delete one.
You didn't delete the Whoops.
And we can clean that up a little bit. Yeah. So that was not changing. It has a red border. Let's fix that. That's kind of goofy.
And the one that changes should only change if you evaluate, right? If you evaluate your model.
Yeah.
But every time you capture a new image, you're going to want to evaluate, right? So
Yeah,
you
I
could
think I
just
might.
draw that every time you like when you capture a new image, just immediately evaluate the model, draw the dot where the model thinks you should turn, and then you can annotate.
I
And
turned.
if you wanted to, you could press the evaluate button and have it do it again and see how it improves.
I turned the border of the red one green, and I left the border of the green red.
Man, I love UI programming. It's
Oh,
so
dear.
much fun. Yay!
I mean, I actually thoroughly enjoy UI
Hooray.
programming, but
Oh, you do? Oh, I'm sorry. Maybe there's a zen there that I haven't found yet. There could be a piece in UI programming that I never achieved.
Well, let me tell you, it all started with JavaScript, and then from there, but here's the thing, though. I started with JavaScript, but making web applications that are mobile friendly.
Oh my God.
So that was a whole other level of like, what am I doing with my life?
Yeah.
So one of my New Year's resolutions is to end my live streams on time or a little bit early. I think we've got mission accomplished.
Are we succeeding? Hey, look at that. Right on the money.
I think we've got this thing drawing and changing location. I think this is going to be perfect. I think you're right. We're going to go ahead and evaluate every time we capture. It'll simplify the UI just a little bit. And
are you on track pardon the pun, for the GTC session?
Yeah.
I am, because I must be. And so
You feeling good though?
I am feeling good, actually. Yeah, because luckily I've got Chitoku's code to work from. And so, and it's even in Python. So I'm not even like translating from Fortran to Python or something weird like that. I'm just Jupyter Notebook to extension, which has some changes,
Dude, what's it like being competent?
Yeah, so we're on track. My goal is to have the trainer and the running complete to show you guys next Thursday. And I don't guarantee I'll have a data set that's working yet, but in theory, if I, just copy all of Tutoku's code, we should be all set. Should be able to just run through this process and generate a couple hundred images.
I'll make a shorter track
One
for
of my
you. So you
kids
can
help me do
easily
the
test.
driving so I can click faster and just capture as they go.
Smart.
Just capture a couple hundred data points.
Amazing.
Yeah. So fun. So if there are any more questions or comments, we'd love to hear them. But as you can see,
I mean,
we're good.
a lot of good people in the community following along, excited, sharing some ideas. So Ashley was there's Ashley. Oh, when Darth.
Yeah, what happened there?
Darth. I don't know why that happened. No idea.
I think
Darth
it's your
Edward.
podcast voice coming out. You're just like you're preparing your announcer voice for GTC.
I don't want to fix it.
We need to get one of those filters, like the cat head filter, but get you the Darth Vader head filter.
Oh yeah.
Going on.
I'm sorry, Your Honor. I appear to be a cat.
Oh yeah, that's funny.
I do need to get a mask.
So, would you rather be Darth Vader or is it Dark Helmet?
Probably Dark Helmet would be more appropriate.
Okay.
Much more my height.
All right. Well, folks, thank you so much for coming, and we'll see you again next week. And until then, make some tracks for us. I can't wait to see what you come up with.
Okay.
Register for GTC.
That too.
Thank you.
Yes, that too. We'll see y'all later.
Bye.